Welcome to part 2 of the video Limits and Infinity. In this video I'm going to show you an example of a problem that can be solved in two ways. And then we're going to do something really interesting. We're going to solve the limit of an infinite sum. So here is a limit that can be solved in two ways. And we have the limit as x approaches infinity of x plus 1 over x. And the first thing we can do is to apply our basic technique, the technique we learned in part 1. So first of all, we need to identify the greatest exponent. In this case, it is very easy to see that the greatest exponent is 1. And then we divide everything by x. If we do this in this case, we get this expression. And then we can cancel out the x over here, and we get this limit. Now this limit is very easy to solve because the 1 over x approaches 0 when x approaches infinity. So this limit equals 1. And there is another way to solve this limit. We can separate the terms denominator. I mean to write this limit like this, which I took the x over here and the 1 over here, and then we can cancel out, and we get again this expression, and we know that this equals 1. So I want just to show you this example because there are many limits that can be solved in more than one way. This is an example of one. Well, now we're going to do a much more interesting problem. We have this limit where in the numerator we have a sum, and we have n approaching infinity, and when n approaches infinity, this sum will become an infinite sum because n is grown. So as n grows, the number of terms grows also. And this sum here is what is called an arithmetic progression. And there is a way to find a formula for the sum, and we're going to do that now. We can call this sum s of n and write it like this, but we can also write this sum reversing the order, starting with n and going backwards until 1. And then what we're going to do is to sum the s of n here with the s of n over here. And what we got, and we're going to sum term by term. If we do this, we have n plus 1 here. Then we're going to have n minus 2 plus 2 here. Then here the next term will be n minus 2 plus 3. And we can continue like that, and finally we're going to have the last term will be n plus 1. But here we can know that n minus 1 plus 2 equals n plus 1, and n minus 2 plus 3 equals n plus 1 too. And you can continue with the next terms, and you'll see that every term equals n plus 1. And here, how many terms do we have here? And we have n terms. So all the sum equals n times n plus 1. So we can write this like this: 2s sub n equals n times n plus 1. So here we have the formula for our sum. This is the formula for an arithmetic progression. So we can apply now the formula to our problem. We have this limit, but we can write the numerator like this using our formula. And we can write this like this, and we can expand this product. And now we're ready to apply our basic technique. The greatest exponent here is 2, so we divide everything by n squared, and it looks like this. Next we can cancel the n squared here, we can cancel the n here and the n squared, and we get this limit. And this is very easy to solve because the 1 over n goes to 0 as n approaches infinity. So this equals 1/2. That's the final answer. Okay, that's all for now. Thank you for watching and see you next time.